Hold on. Let me change something. Yeah. Yeah. Sorry, the chair I was sitting on was bad, so I had to change it. Yeah. So we need to now define the architecture. So now, what is the architecture? In plain English word, what is architecture? Anyone? So architecture is basically the design, okay, the design and also connecting the various components to form as what your base foundation. Okay, so the base foundation basically is the architecture to which the various components and all that it takes will actually sit on. Now the components, so the components are basically the various areas of the development. For example, if you are developing a school management system, so first of all, the student has its own components. The course registration has its own component. Fees has its own component. Um, Staff also have their component. There are so many areas that we can actually look at. Then the interface. So the interface is basically the connectivity to those components. And the data structure is basically how data is being formatted. Okay. How data is being formatted, like in JSON. For example, it depends on the interface on the programming level. If not, maybe you are looking at the database. The database has its own structure where we can have data, some data accepting integer numbers, also numbers, string, and the rest. But we're also looking at how the component will have the interface to which other components will connect to. So think of an interface as our sockets. Some sockets have 3 pins, 2 pins. Okay, so this is the interface, which means that the other points you have the other interface that will actually understand how they will communicate. And the algorithm is basically, the logic. Okay, and all this must satisfy what we agreed as what our requirement engineering. Okay, it is the creative because we don't have any one single design. Okay, you don't have one single design or there's no one single way to success. Okay, so it's basically the creative and the technical bridge between what of the requirement engineer and how of the implementation. So based on the software requirement, what requirement do we need and how do we implement based on the requirement? So you say that if requirement engineering answers what must the system do, the system design how, how, how do we develop it? Because you are saying that the architecture says that we should develop a 3-bedroom. How do we develop it? What are the materials? What are the components that we need to mix in terms of the concrete mortar? All this actually comes into the software design, the color of the building, whether we are using blocks, bricks, everything actually what comes in here. So you see that every major decision made during design, that is how to organize the code, how the component communicates, where the data lives, and how concerns are separated would directly or determine the system quality, the cost of maintenance, and ability to evolve its operational lifetime. Which means that if you have a poor design, no matter how much the code looks very, very neat, a poor design is a poor design. Imagine I normally use building because it's very, very easy for us to visualize. Okay. So the building, we are supposed to build 4 bedroom. And the bedroom, 4 bedroom apartment, mistakenly, you did a 3 bedroom. Even though the measurement, the 3 bedroom, the measurement is actually superb, we cannot use 1 bedroom to be partitioned into what 2 bedrooms so that in all it will become 4 bedroom, which means that maybe another foundation, another extension that will actually alter the entire design and also may have some cost implication in there. A well-implemented system built on a weak architectural foundation will become increasingly expensive to maintain, just like that uncompleted store building located at the Osu beach. The building looks nice, but however, the foundation does not support such building. So I'm told the building is sinking. The building is sinking. Now you develop a system whereby it can take multiple payment channel. For example, Momo, maybe Momo, MTN, Telecel, Airtel Tigo. Then you come to the Visa, PayPal. Now, for example, there's a new payment in town. How are you going to what? Attach to it so that the user can have the luxury to what? Include a new, to select the new payment gateway. So first of all, imagine that, our admission has Momo for MTN, Telecel, and Airtel to go. And each of them has its own logic. Each of them has its own interface. Now, you only design for the three. Now, the master students are saying that no, I mean, I can't go to, Momo actually what has some transaction fee. Okay, every transaction, has a penalty, or when there's a charge. But most of us, we have bank ATM, and bank ATM actually charge at the end of the month. So no matter how much you withdraw, the amount is fixed, unlike the mobile money. And honestly, I like using the ATM. The ATM has its own pros and cons. Once your ATM card get lost and you don't block it, you are doomed. Just like the Mumu. So me, I prefer because at the end of the day, my bank may charge me 10 cedis for all the transactions that I want to do within a month. Irrespective of the number of transactions, once I don't exceed my daily threshold, I'm good to go. But for the Momo, every transaction deducts some fee. So imagine the school say, okay, now we want to allow electronic payments in terms of Visa and MasterCard. Because your code has been designed to take only three. Now, if you add a third payment, you need to go to drawing board. Now, erase some logic to accommodate this new feature. That will actually cost you so much. But whereby your design is such that you can actually attach more payment gateway without any problem, you are good to go. Within some few, maximum 2 hours, it should be enough for you to what? For people to start using. For example, your car had been designed that it take only 3 wheels. Now you want to now add 1 wheel to make it 4, which means that the entire design, you need to change a whole lot of the hardware, molding and everything. You need to change a lot. But whereby, for example, uh, uh, like those cars, those Toyota that we have, most of them are right-hand drive from Japan and other countries, you understand? But because they have made the same, they know people may be using or maybe now changing the steer and everything to the left, they've made provisions for. So which means that the time taken for you to move from one place to another wouldn't cost so much as compared to that car was not designed to have 4 tires. Or no, that car wasn't designed to be driven on the left. Now you want to drive it on the left, you will have a lot of problems because this is not what it has been naturally been designed. Okay, so there are a lot of design principles that we'll be looking into. And the opposite is also true. A well designed system is resilient, adaptable, and pleasure to work on, even years after it was first written. So these are two types of designs. We have the architectural design and also the detailed design. So the architectural design is what you call the high level. So look at the high level, how the building will look like, not bringing major, going deep there, deeper. No, 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 no. You see, no, if you see this architect, this civil engineers, we have the normal overview or the architectural design. Then in each component, you may have the individual structure with the measurements and what have you. So this is what basically this will be what looking at. So for example, the architectural design of the school management system will actually draw only the components. This one will connect to this one will connect to this one will connect to this. But when it comes to detailed design, for example, let's say the finance model, now they'll go deeper to break it down for development, because the detailed design is where the engineers like you and I, or the developer like you and I, will be implementing. Then later, this one will actually look into what? Connecting those components together as one system. Any question up to this point? Now, what makes a good software design? I mean, as you all know, the correctness, okay, the efficiency, the flexibility, the maintainability, the reusability, they are quite a lot. Okay. Now let's look at the design process. So design process is not kind of a destination. Okay, you don't get to where you say, oh no, because even our software that we have today keeps on going under updates. I mean, systematic updates, being it our operating system or any software that we have, they often go into systematic updates. Even though even at the operating system level too, we have all these updates ongoing. So it's basically a process. Now that uh uh we have the AI, has even really disrupt a whole lot of what processes. And the competition is very keen. And when ChatGPT came, they came out with the course, and they were telling us it costs really so much to develop. But then the Chinese came with saying that this is a lie, because they use a fraction of what they were saying to develop such a system. So you can see the competition is very tight. Okay, the competition is very tight and very keen. I just want to show you one of my code. Yeah. So it's saying that it is not a single step, but then an iterative step activity that will typically follow this progression. So it's just like a loop. You do, you check, you come again. Maybe there's a new idea. For example, if you go to some websites, before then, basically your username and password. But then an update came whereby I don't want to create really kind of a username and password. I just want to now log in using my existing uh existing platform. For example, if you have Google, if you have Apple, they'll say log in with Apple, log in with Google. So that at the end, you don't need to, r- memorize all this username and password, unless maybe you save it elsewhere. But then with this software design process, you realize that it's basically an iterative what activity. Like the WhatsApp that you see, the interface that you have now, it wasn't like that before. It goes through changes. Now they have this AI feature that you can quickly ask questions and they will what, be ready to what, answer you. So instead of, you need to understand the requirements. So you need to read the software requirements specification, the software requirements, the SRS, the software requirement specification, so that it actually make you very clear exactly what your customer is looking for or what exactly that you are building. Now, you actually identify the major component. So you actually decompose the system. So for example, the school management system, okay, is huge because school management system comprises everything that the school is doing. So we have the students and the staff are the two main components. Now, the student, what are the things that we need? Pre-admissions, admission, course registration, tangle with fees, uh, result moderation, publication of the results, then graduation, library. I mean, it comprises everything. Now you come to the staff, HR, leave, appraisal, promotion, committee. There's so much. So when you're able to break all this down, then you can actually start developing them. So you need to define also responsibilities so that you don't have one code interfering into another person's component. You understand? So assign clear non-overlapping responsibility to each component. And in programming, one component should be doing something which is unique from the other. You can't have two components doing the same thing. Just like our building in our house, our sitting room is for watching TV, our bedroom is for eating, bedroom is for sleeping, our kitchen is for what? Cooking. You can't use the kitchen for sleeping. You can't use a sitting room from cooking. No. Even though you can do it, but then it doesn't speak well of you as a person. Now, you define your interfaces. How do your components communicate to each other? Other APIs, events, share data before implementing internal. So I want to show you one code of mine. So as I told, this is basically C#. I know maybe if also most of you are C# developers, I can't really say. So you realize that this is a church management system, and the church management system, I'm using solid principle and other design principles. So my program is divided into three different modules. We have the controller, we have the services, and we have the repository. So you realize that, for example, let me take one of them like this one. So for example, this one will return a piece of data. So let me come here. So this one will return this data. Okay. And this data is actually shared data. Anyone who actually patronize this particular function or method can have access to. Okay, can have access to. So we can have the internal data, internal sharing of the data or column of the data. Then we have another type of data that at the end they will be sent from our system to an external system. So this is where the API comes inside. So I have a controller that can handle that. So you realize that this is actually the controller. So the HTTP, you let you know this is a controller. And based on the logic here, it will return the feedback. Okay. It will return a feedback, return okay, which means that it will return 200. So let me show you. Mm, let me show you one. Let me show you one. Uh, let me show you one. So we have these members. Let's see. Yeah. So let me show you here. So you realize that there is an API which is being called. So when I call it, I get unauthorized. And this is the unauthorized or session expired. So when I come here, there's an API called user. Okay. But for me to really know where this one is, I can just copy this one, come to my code and paste. So you could see that code is sitting here. Okay. The code is sitting here means that if I'm actually trying to log in and the login has some problem, it will fire an error. And the error, you can see that phone 401 unauthorized. As you can see here, 401 unauthorized. Then, if that's the case, then it returns this particular error to the user. So we call this one an API. So we have an API. We have different types of, we have the API, we have the graph QL. We also have a few others, but then I normally use the APIs a lot. So some of the data are shared within internals, and some too are shared across the systems. Now, choose the architectural pattern. Select a pattern that fits your system quality attribute. So building such a huge system, you can build it alone, but then you have a lot of what problems. I must say, this application that I'm building, I'm having a lot because I'm the one developing everything from front end to the back end. Everything is being developed by me. So which means I may not have all the ideas in here. So some of them may be overlapping, but I don't care because I'm the one developing the whole thing. I'm the one developing the whole thing. But then if you find yourself in a huge company, you are not going to develop, if you are going to develop the whole thing, you have a lot of clarity so that when you are developing, there's no stopping back. Now refine iteratively. So which means that once you're able to move from the high level and now breaking down to the low level, now you go to each one, whatever you develop, you test. If there's a new idea that will actually be fine, will be way better than the format, you just implement it. Then you document the design. And this is actually most problem for software developers. We don't like to document our work. So often we have this thing called the pair programming. So as I'm developing, you are also documenting whatever I'm doing. Okay. So you realize that even your final year project, when you guys form a group, we have some people who will come to look like, oh, mine is to what? I don't have time for the development. So mine will do the documentation. At your level, you should be doing everything, Sam. Now you review and validate. So you actually go through to make sure that everything that you are developing actually meets the validation of the customer. The validation of the customer is very, very, very crucial and very, very important. Okay. If you have any question, please feel free and let me know. Okay. Now, design and implementation. Design and implementation. So the design, you are looking at the structure, the relationships, and the responsibility. And this one, implementation is basically writing the code. Okay. Now, for this one, you do sometimes on the low level, you design the architect. We can use some drawings or diagrams to help you understand how the various logic is going to look like. Okay, so just for you to understand. Then the implementation is now putting it into what code. Okay, putting it into what code. You understand? Design decisions are the most expensive decision to reverse. Why? Because it is actually your style, everyone and its style. Once I'm developing that way, so be it. It's very, very difficult to implement two or more different design don't that they don't talk to each other. Okay, so my design often is the repository design. Okay, so if I say repository in normal terms in programming, repository is basically where you have access to the DB, okay, the database. So you create one model, okay, whether staff or the students. Can you hold on for me? Where it's actually have connectivity with the database. So I have what you call the repository. So if you could see, let me see. So let me let me take this one. iService repository. So iService repository, okay. You realize that I make a connection to the DB. Okay. So these are some of the syntax for C#, but don't really understand. I want something which so this one, some of them is very easy on the eye. You see dot where. So dot where is basically I'm making query to the database. Okay. So where like the SQL query, where I'm saying that the issue filter only the E status or the EDO status, which means that there's a table that had a field called okay status. So she only gets me the status and that's all. Okay. In some here, you see where, okay, where, okay, you see that where this, and this. Okay. I know it's very confusing to the eye. So you could say this one E, this one is showing if E doesn't go, it's not null. Or if E dot status is not empty or null, you should fetch all of them for me. Okay. And meeting types. So you can see where I'm making a comparison, which means that I've passed in a variable here. So I'm comparing whatever is to the particular column, the particular table column. So the table is called the meeting types. So let me connect to the database for you to see. So I've connected to the database. So the database, one of them is called the meeting types. Are it church meeting types? Uh, you see this one, yeah. So the meeting types, one of the column is called hierarchy. Oh, sorry, the level. So you could see that the level is what I have here. So when I come to the repository, so you see that the hierarchy dot level is equals to this one. Okay, it's equal to this one. So which I'm making a comparison as here. So this is basically an SQL query in the form of what C# or ASP.NET Web Core framework. I know it's, but then just to show you that how things work. Okay, and I'm sure all of you are actually what developers, because if in that sense it makes things very easier. Now, let's look at the design principle itself. So they are basically the fundamental guidelines and the heuristics. Okay, so the heuristics is basically the ability to design or to come out with something. You understand? Where it comes from what? Experience. Without experience, chairman, you can't. Without experience, you can't. So that at the end of the day, It's like someone who know how to dress every occasion and the type of dress, and he's always on point. So which means that it takes experience to actually what? To be in that stage. Good job. Okay. It takes so much of experience. They are not basically, they could be rigid or not. Okay. As the book is saying, I believe I shouldn't be so rigid. But actually to follow it to the core and to maximize the design principles, you may need to follow it to the core. But especially where you want to now fuse two or more design principles, you should be very, very careful. And it says that a design that violates multiple principles is certainly heading towards a maintenance nightmare. Why? Because, for example, you design a principle whereby you've created a logic to paginate information. If to say paginate, it means that if you have 1 million records and the query is to return all the 1 million records, it's quite impossible because it will actually end up freezing your computer because the memory cannot handle such records at a go. So what they do is they do what you call pagination. It shows then a number of data at a time. Let me see if I can remember. Hey, do I even remember my username? Wow. I think I've forgotten my username. Okay. Let me check if I do remember my username and password. Do I really remember my username and password? Oh, it seems I don't remember my username and password. Oh, but I remember the password. And I what? Let me check here. Okay, I remember. So it's M0101. Uh-oh. Oh, okay. Yeah. So if you come to, let's say, members, okay, so you can see that these members are only 4. So you see that it's showing 4 per 4, but then we actually need about 25 per page. Okay. So this is how the pagination really works. So that's the pagination I was referring you guys on. Okay. Now, there are so many principles that we have, and I'm much familiar with this one, and this one, and this one, and this one. So let's quickly go through them. So we have one. The first principle is, and this one, some of them are general, it's abstraction. It says expose what is necessary, hide complexity behind simple interfaces. And the idea is to reduce cognitive load, enable independent development and testing. Let me give you an example. Now, If your child, this one I want you guys to answer me. If your child comes home and say that Akosombo give us electricity, and your child want to know, but Akosombo is not in our house. But how do we still manage to get electricity to use in our homes? What will be your answer? The question again, your child comes back from home, from school, and he says that, I mean, Akosombo is not directly connected to our house. But anytime Akosombo has light, we have light. When Akosombo goes down, our light goes down, but you are not directly connected to Akosombo. What will be your answer? Anyone?
There,
Yes, Sarah.
please, I'm trying.
Oh, why not? Feel free.
I can say maybe Akosombo is the source of electricity, but not um is the source of electricity, but eh,
No, I mean, how can you how will you let him understand that Akosombo, there's no cable from Akosombo to your house that you can say that this cable that you've connected actually goes through from your house to the Akosombo. But when Akosombo goes down, your light goes down. Anyone?
Hello, sir.
Yes, sir.
Yes.
Prince.
So I'll say the electricity, they have a substation maybe around the town where I live. So, and that substation is directly connected to maybe the Akosomo Dam, but we are not directly connected to the dam or the Akosomo.
How? How?
No, I mean that
So how will you
from
know?
my,
So the question is, he comes home and says that, I mean, do we have a cable from our house to the substation that you are saying? Is there a cable from your house to the substation? If not, how come if Akosombo, the substation goes down, our house also goes down?
so like I said, there's a cable from the house to the station, the substation.
So can you identify, if possible, can you identify the child, which one is your cable, and when it gets to the outside, which one, can you trace your cable up to the substation or not?
No, it's not traceable.
Why is not traceable? It's not traceable because of the principle for abstraction. So what they do is that ECG will only tell you to connect to this cable. As to whether this cable do internally in ECG, you don't have to know. I hope you understand. Wow, is it Prince or Sarah? I hope you
Yes,
understand.
I
so
understand.
So which means that the ECG will only give you an interface for you to connect to that source. As to what happened in the substation up to the Akosombo, you don't need to know. So you only expose what is necessary. Just like a car, yours is to press on the accelerator paddle, the clutch, but whatever happens in the engine, it is not your responsibility. That is why when those stuff develop faulty, you give it to a specialist to work on that. So what happened is that you only expose what is necessary, and you can do through what you call interfaces. Let me show you my code. So you see, I have what you call an interface. So the interface basically, as you see here, is the name of what the method, and the parameters would know anybody like what you know to be like this. The moment you put something there, it will give you an error. So that's how the interface, and to know this is the name, public interface this, that's all. Then you provide your method name, okay, your method name, and if there's any parameter and the return value, that's all. Aside that, nothing else. So you realize that if I come here, I only expose, but the other receiving method need not to know how it is done. Look here. So you could see that I actually call that particular interface and I feed in that. And this one is just the connector. Whatever it receives, whatever is also returning. So I need not to expose whatever is there, how it works. What I can show you is basically the name of the interface. That is all. As to what this function actually would play with your data, you don't have to know. You don't have to know. So basically, this is how the abstraction works. And I don't know, per your syllabus, do you have Java or any programming language that you guys need to do? Do you have any programming language that you need to do?
Sir, please, you mean a language will be doing?
Yeah, or language that you've done so far. Have you done any programming language yet?
No, please. Okay, so
Hey,
we are doing the Visual Basic and then the HTML too.
which level are you guys in?
300.
You started as top up or from 100?
No, top up.
Oh, okay. But you've never done any programming language in your life, Serum?
Hey, sir, please. I did the basics of C++.
That's all. Only C++?
Yes, sir.
Wow. Now, modularity. So you actually divide the system into what? Well-defined, independently what? Manageable units. Okay, so the reason being that if there's a problem in that particular unit, you only tackle that problem. As you see here in my code, all repositories are in one folder. All repositories are in one folder. So if I have this repository being a problem, the other files here are not affected. Unless there's a connectivity, I need something that this one has. But if not, if this one is the problem, you actually tackle that problem. But if there is kind of interdependence, that is when it may also affect the other side of it. Just like a car with 4 tires. If one of the tires goes down, you should know that the car cannot move. Even though technically it can move, but then the discomfort will be too much. So which means you need to fix the other tire so that all the tires will be what? Okay. Okay. So modularity is very, very key. So you realize all the repository are in one folder, all services are in one folder, all models are in one folder, all other stuffs are also in their respective folder. Let me open another. This one, I normally use the repository design pattern. Then also have another one that I developed for a payment gateway. Um, Yeah, so you could see that this one, they call it the clean architecture. So you realize that it has different structure. Okay, so this is the structure. So I have four main. So you have the core, and the core contains the entities or the models, the interfaces, and the use cases. So the use cases are basically what they are doing. If someone want to log out, you should come and pick the code here. If someone to do that, you should come and pick the code here. These are the use cases, and these are the frameworks. So the framework contains the controller, the repository, the route, and all this. So every design pattern has its own folder structure. Then we also have what you call the encapsulation. So encapsulation is basically hiding the internal implementation, which is the private part, just like the human being, and you only expose the public interface. So for example, if you go to the ATM, okay, the ATM will allow you certain questions and you respond. Okay, so at the end, it will ask you for your data. I mean, your card code and the rest. And those one are seen as what a function that will accept. But then technically, it will be used as a variable. Let me create a simple code here for you to understand. I'll use IntelliJ. Hold on, let me create an IntelliJ. Okay. So let me say top up bit. So I'm using this, yeah, and create. Okay, don't worry. Yeah. So this is my project, and then oh, something is missing here. Mm, no, 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 I don't want something like this. No, I don't want something like this. Oh, but I don't know why. Uh, no, I don't want this. Let me open VS Code. Okay, I like to use. Let me use VS Code. Let me create a simple application on desktop. I'll say my Java. Yeah, so I'll go on to create index. Yeah, this is Java. So I'll say okay. I'll say public class index. So basically I've created a simple, and then let me create another one. I would say fee calculator or fees. Okay, just something. So normally, if I want to, let's say something like South, please please enter your name. Okay, then I'll do something like this. Okay, so you see that normally this one, when I run this one, let me run it for you to see. Okay, so you could see that now I have what you call please enter your name. Okay, and this string will be visible to you that I have a string that will be receiving your details. So you could see that it will come, it will now be printed your name. Okay, it will print a hello, then the name and the exclamation mark. But the problem is with this one, I'm exposing the internal details of this one. Okay, I'm exposing in the internal details, which is what the string name. I don't want this one because it is my secret. If the outsider knows that there's a name variable which I have labeled as well name, it can actually try and hack to know how this one works. So normally what I'll do is that I will create what you called a private variable. So I will say private name, oh sorry, private string name. This is actually in Java. So if you don't understand Java, don't worry, but then just understand I would say public get name. Then also public string get name. Then public void set name. So so I have what you call getters and setters. So what I'll do is that I will never expose this one because the moment I expose, it becomes a very big problem. For example, if I say fees, then student fees dot new fees, okay, and I come to do, oh sorry, if I come here, I'll do student fees dot student name, okay. So if we see that, I'll have a problem say that the field fee name, the field fees dot student name is visible because this one is what a private name. But in the moment I do it public, you realize that it will go off, which is not actually good as what a developer. So those variables should stay private, and those functions, this function and this function will stay public. So you can see how public. So instead of this, I can say I can say something like this. Okay, I can say something like this. Then this one will actually what? Take it. Then here, then at the end of the day, this function will get this one. Whatever maybe I can do a whole lot of here. I can do a whole lot of here. I can add something here. Okay. The person wouldn't know what this function is about because here I only expose the function name and the parameter. That's all. Whatever I will do behind the scenes, the person will have no idea. So that's what you call the encapsulation, and the separation is the separation of concern. So you give each component exactly one defined responsibility. Okay, which means that every function should perform one single function. So for example, if this function is to get student name, this function is to what? Actually accept student name. That's all that it does. It doesn't do anything else apart from getting the student name. But not to do this and to be asking for the age for this. No. This one is for only one student name. So at the end of the day, that's the purpose. So we have what to call the single responsibility. Single responsibility. So which means that anyone who actually see the code will know that, okay, this one actually per the name is set the student name, which means that this one will actually give this student name to a variable. And so be it. But whereby after getting the student name, it does something that is not related to the method name, it becomes difficult for someone to what handle or to continue. If let's say someone who was working on the job stops the job and another person has been hired to take over. You understand? So it will create a lot of problem for the user. So you need to make your code very simple and short and maintain such design principle. Then you also have the solid principles, and the solid principle, this one means single responsibility, just like separation of concern. And this one means open for addition, close for, hey, I forgot to know. Oh, open for, oh, this thing always confuses me. Let me ask Google right now. Open for modification, no, open for addition, close for modification or something. Let me quickly get it for you. That's what I use. Open close, sorry, open close principle. Open close principle. So the open close principle looks like this. Oh. Yeah, you should be open for extension, close for modification. Open for extension, close for modification. So I did something here. So let me get quickly AI to make my work easier for me. I'm coming. So yeah, so let me get one simple example that I can. Principle. Yeah, I'm trying to get one for so mm, mm, okay, so let me get one simple one for you here. So if you come here, let me create one called shape. Okay, so you're actually creating shape. So then I'll create, no, I think, let me create it as interface. I shape dot Java. Yeah. So what I can create here is double area, okay? Calculate area. So now what happened is that, let's say I have created, or let me create one that is going to like bad shape calculator. Calculator. dot Java. Okay, so I can say, so normally have something called double objects. Okay, and I will say normally I'll come and say, oh, I'll come and say for example, if shape is instance of shape, then let me create what you call shape. Oh no. Oh, see. Kindly hold on for me. I'm just doing something which is not happening. So one of the shape, let's say rectangle. Okay, rectangle. Yeah. So if calculate area, if this one, so let me see. Okay, it recognizes it. If it is, then maybe you write your own logic. What should you do? Oh, uh, if shape is instance of a circle, else return 0. Okay, so let me create one for circle. So I will say circle, yeah. So I have this. So you realize that anytime, for example, your application can calculate area of what? Circle, and area of what? Circle and rectangle. So which means that if there's any additional so let me create something called double area is equal to 0. So which means that if area is going to this, then let's say you can say area is equal to this like this. If it is so which means that if you have something like this, okay, if it's something like this is how it's going to look like. Okay, so which means that if you want to add a shape, you create a shape and come and say if else, sorry. So we're adding else, if else, and which is not good as what? A programmer. So what is saying that it should be what? Close for modification. Okay, close for modification, but open for extension. So in order to do that, we use the interface. So when I come here, I can say this one implements I shape. Okay. Oh, sorry. Yeah, something like this. So that whatever you do will only be within that particular circle. If I come to this one and I say, oh, sorry. Why am I typing like this here? So you could see that it is very easier to work on some of these things. So which means that if you are looking for area has its own circle, rectangle has its own logic here. So which means you don't come and what bother what you have here. Okay, so if you have a new distance, so which means that to come here to have a calculator, okay, so I will say correct calculator. Okay, I can just come here. I can just come here, okay, and I write one simple code, calculate area, and that is all. Okay, I can just come here and do something like this, and or even here, I can say, yeah, calculate area, then to actually do the how do you call it, the calculation for me. Okay, so here I don't write so many code. I write only few lines, and the rest of them will actually take its course. Okay, they will actually take. I know it's quite, I mean, a bit difficult because software engineering are actually for those who have actually, or those who are actually into coding. So it make, I mean, explanation quite easier. Okay, it makes explanation quite easier. So you could see that I'm using the I shape as a key, sorry, as what a parameter here. So when the parameter, you could see that the I shape has what you call double calculator. So which means that if you use it, you need to have the calculate area here. This one can be just calculate area. It doesn't really matter. It doesn't really matter. You understand? So however you want it, it doesn't really matter. So you don't write so much for a little. Okay, so you actually write a little, which actually happens in that math. So you could see here, everything come and do it here, everything come and do it. You need to put if else. No, but what you do is that you use a keyword called implement. Okay, implement, implement, implement. As simple as that. So that if you come here and you want to calculate area of a circle, uh, you can come here. You can come here and can say, let me rub this one. You can say, oh, you can, he has written quite a lot of code for me. Okay, so you could see that here. Let me do scanner. Let's close. You know, they have this AI already embedded, so it doesn't write so much for me. So if you could see, this one actually has, is looking for width and the height. So what he can do is that he actually assign it to or he actually assigned to the rectangle class, and he actually initialize it with this information. Now, when it is done, it's actually called the correct calculator class. Then the area is calculated based on this. Okay, so because if you go to rectangle, here, the rectangle has a method called calculate area. So this one will actually do the calculation of the area and calculation of the area. So this one receive the area and you give it to this one. Okay, and you give it to this one. So this one will also do this and actually do the calculation of the area based on the shape. So if you look at this carefully, it's more of like we are running in circles. Let me see something here. Yeah, so you could see that it basically gave me the area of the circle, the area of the circle, as simple as that, the area of the circle. So let me see this one. Let me see this one. Yeah, so you could see all of them give her the same functionality. Okay, this one gives the same functionality. So you realize that the shape here, as you can see here, takes this. So this one, by then, this one have done all the calculation already. This one would have done all the calculation already. So even this one, we may not even need it, or we may need it somehow. We will need it somehow because when you come here, it only return the I shape. Okay. So now, also to help you understand further, what you can do is you can place in what you call a debugger. So a debugger will actually help you to understand whatever. So you could see that it stops here. Okay, it stops here. So you can go to step inside the code. Now it comes here. Now it goes to the object. Now it comes back here. It goes to this one, the calculator. So the calculator is basically go in here. Okay, you see, then it calls this one. Okay, it's actually called this one. Okay, so we can do is that we can okay. So so let me see. Let me show what is happening here. Okay, let me show what is happening here. So what happening here is that when this one gets here, it comes to this one. Okay, it comes here. This one is not even called at all. It comes here and assigns whatever was passed here to this two private variable. That's the end. Then this one now calls the correct this one. And when you call the correct this one, okay, it comes here. Now this one comes here to calculate the area of the triangle, but the triangle comes from here. And this one already implements the shape, if you see it here. Okay, so which means that the shape actually, which is the shape, and the shape here is what? The triangle. Okay, this is what? The triangle. Okay, so the triangle, okay, the triangle, oh, sorry, where am I? This one, the triangle. Okay, so the triangle is actually what is being passed here. So the rectangle, which is actually what rectangle. So which means that since this one implement, then definitely it's going to work the magic and get you the area. So you could see that even here on the rectangle, this one is not even noticed or even seen, but yet it has been what? Worked on, because this one has calculate area. So it is hidden. So if you are very careful about programming, it's all about connectivity, 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 connectivity. Okay. So that is for the solid. There's quite a lot. So we need to look at the Liskov principle, and we also need to look at the inverse, the interface segregation. Okay. They also have what you call the dependency inversion principle. These are actually solid principles that it has been developed that we're all using. Then also don't repeat yourself. Okay, don't repeat yourself. So if you have a function that calculates your GPA, you shouldn't go and create another function that okay. You shouldn't actually be repeating the same logic everywhere. It should be one logic which you need to call it everywhere. I was involved in a remote job with some Indians. Okay. And Indians too are very good developers, and some of them too are very bad developers. So we are creating just a portal where it only displays data from the database. That's all. Now, as I told you, the data should be paginated. So what this guy did, he created the same. I mean, it was about 20, almost 20 pages or 20 different portals. And all of them, you filter the data and it will display on the screen. So just like what I have developed here. So if you come here, there's another one, yes, another one, there's another one. And all of them you realize that all of them has, you see, all of them have this pagination here. Okay, all of them have this pagination here. All that you see, all of them have pagination here. You see, all of them have pagination here. You understand? So this is telling you how the pagination works. Now, what this guy did was that he created the same logic 20 times. So if now one of the logic goes bad, or if you see an error in the one logic, now you need to go into the 20 pages to go and correct one by one. But if he actually created one logic that will handle the pagination, which means that if there's any problem, you go to that function which is being called multiple times. Okay, which is being called multiple times. Then you only solve that particular function. Then the error will be what? Will be eliminated from all the 20. But then he created, for example, he came here, created one, you go another page, created the same, this, another one, 20 times. So if there's a mistake here, you need to go to all the 20 pages to what? Make that changes. So that is the problem of what really happened. That created that problem that I was, we are using. Any question whatsoever? So, and the thing is, keep it simple. Make your, if you keep it simple doesn't mean you write uh kit code. No, your code should be very, very complex, but should be very simple. Or you should write the code that you really understand. Not maybe you went to copy the code from elsewhere because the code works. That is all. You need to understand how the code works. Okay, and also write a code such that if you are the developer who wrote that code and you are gone, no one can actually work on the code unless you yourself. That makes you a genius. You can't write any prostitute code, then anyone can come and what? Update it. No. Or come and what? Diagnose a problem. Okay, that actually makes you a very experienced developer. Now we also have what you call, you aren't going to need it. Okay, which means that you write, if you are not going to need it, please don't include it in your code. Okay, you don't use, because it's going to be waste. I have some, I understand, but the reality is that it's going to be difficult to do that because there are some code that initially I wrote that I no longer use it because the dynamic of what the direction changed or the requirement changed along the line. But if you were a team, we would have taken serious to delete all that we don't need. Okay, and all these principles that you see here, they are quite a lot. These are not the only principles that we have. Okay, we have so many principles. Okay, so this is what I often use. Okay, but even this one, the open close principle, I have another one here. Let me show you. I implemented what you call the factory pattern. Okay, so the factory pattern, if you look at it carefully, so you could see that I have two, three, no, only two, Momo. So now the cash, if the person is actually what paying by cash or by Momo. Okay, then I also have another one. If the person is sending information by SMS or by what? Email. So I created there's something called factory pattern. Okay, factory pattern. Factory pattern. So basically, now as you go along, definitely you are going to see more and do more. And also, it's very, very important that you do more. Okay, so that it be part of your portfolio. So you see here, I call the pattern. Okay, so this one requires the type of service, because the type of service will let you know whether you are actually paying by Momo or whatever or cash. So you could see that I don't even show whether it is cash. I don't even see. You are not even going to see. Okay, so per the service that the person is going to pay, then I do the justice to it. You understand? You understand? So as you go further, definitely you are going to understand more. But as an engineer, as I said, you need to have a lot of experience in software development. So these are quite a lot. So I'll leave here. You go and actually read the rest. And if you have any question, you come and I'll help you with the answer. Okay, so it seems that whatever we did is whatever they have actually explained them into details. So I'll only explain in a nutshell, then you can go on to what, look further. And everything is on, this one is in Java. I think, yeah, it's in Java. Java and C++ have much similarity in here. So this was open for extension, closed for modification. Okay, so this is where he explains it in details. Okay, so you understand. So this is what even me myself I did with the factory. The factory actually go by if else. If you look at it carefully, I have the same if else here. Let me show you. Yeah, so this is the if else. So by this one, I use the switch case. Okay, instead of the if else. Okay, so here, what you create an interface. So the interface will just implement the payment method. So you need to create a payment method called process, and all of them will have the same parameter. Then you can go from there. So any way that you want, wouldn't be a problem. Okay. So this, if we're doing, if there was another course as a programming language, as we are building, then we are actually also developing to show in real time how basically it really works. Okay, and this one, interface segregation principle, is one of the nicest. You see that clients should know before to depend on interface they don't use. For example, if you say an animal, okay, and if you declare an animal, for example, interface animal, and the animal can fly, an animal can eat, but not all animal can actually fly. So if you create an animal which implements you create a type of animal which implement the animal, which means that now the animal should be forced to fly. While the animal, for example, an elephant, shouldn't be forced to fly. So which means that now you need to segregate the interface to actually go for exactly what it's supposed to do or it's supposed to have. Okay. So this one, it requires that you be a proper programmer. But then as I told you, I'm all here. If you need so much support, I'll be willing to what help you. So you could see solid is the one of the okay. So as you are reading, I'll leave a lot of tips. I'll leave a lot of tips here so that it will help you guide you what you should expect. Okay. So we have the so the architectural that I'm using is more of like the multi. So I'm using the repository architecture where we have the controller, the service, and the repository. Okay. We also have the MVC controller. This one, when I was learning PHP framework called Laravel. Okay. So they have the model is basically the data from the database. The V is what the browser shows to the user, and the controller is basically receiving the request from the browser, and it will hand over to the backend, which the model will be what will actually work on. Okay. They also have the microservices architecture. You know, sometimes, for example, an e-commerce, for example, Alibaba, what they do is that they don't have all the architecture sitting in one computer or one server. They'll decide that, okay, the staff will be on one server sitting elsewhere. Let's say the appliances will be on one server. Float will be on another server. User credentials will be on another server. So like they've created, everything has been designed as a simple and small, which called micro, and they will be communicating with each other. So they say some service, that's what something they say. For example, let's say they say Twitter is down, but realize that other countries are not affected. They say this service is down and other functions are actually working. It's all by the what? The micro services. So which means that the micro is actually what? Disintegrated, okay, into smaller units, and they actually being connected together. So one service may be down, another service may be up. And if I say a service, basically what that particular server has designed to do. As I told you, maybe that server is supposed to handle user and staff login. Another one is to handle, like if, for example, the school management system, one server handles the student application and the admission. Now, another server handles student registration. Another server handles student payment of fees. So you could see that, let's say if the fees is down, okay, the student registration is actually working perfectly. You can log in, but just that you cannot view your payment. And if you cannot view your payment, you cannot register. You see that the course registration page is there, but just they cannot register because that services depend on the finance services that will allow you either to register or not to register. So it's very, very clean, and it is also quite complex. So you see, disadvantage, distributed system complexity. You understand? They also have event-driven. So event-driven is basically where data is needed in real time. Okay, so when something happens, that is when something should happen. So that's called event-driven. So what happened is that this one is normally used in real-time systems. So for example, like this e-commerce, you know, when you are on a page browsing for some item, you ask to be there. Back in the days, if someone has bought the item, the page will not refresh for you to know that the item has been bought. Only when you get to the checkout, then it will tell you the item does not exist. But in real time, when someone buys an item, you see that now the item has been bought, you cannot buy. So they have what you call a message broker system, like the Kafka I know of Kafka and RabbitMQ, but I know AWS and other super weight vendors have this. So what they do is that it's like a chain, or it's like a system whereby they receive messages and send it to what? Other people. So this one will consume the message and this one will produce the message. Okay. So one will take it and give it to the other. So, and this one is designed the way that if maybe the receiver of the message is down, the system will actually be keeping the message so the other system is up. But in the normal API, the API works in a way that after some few seconds, if the other end is not responding, it will actually discard. And if it discard, which means that you float that data, unless you restart the data, we restart the service. But this one doesn't work like that. It will be there, maybe it can be there for 36 hours, depending on your configuration. Okay. So, yeah. So you see, consumer can process new events when ready. Real-time processing, easily add new consumer. Example, easily without modifying easily add new consumer without modifying producers. Okay, so one will produce the message and one will consuming. And you see for real-time system, okay, order processing and all of this, okay? This one I have not heard of it before. The hexagonal architecture, I've not heard it before. Then pipe and filter. This one. Okay, now this one is not for. I understand the pipeline, but I'm trying to look at. This one also like real time or something, but then this one has a lot of similarities to this one, the event-driven architecture. So these are actually the category, and you guys have a lot to learn though. So also the tools. So one thing that you guys need to go and learn is the UML. Okay, the UML is actually the de facto way of expressing or modeling the architecture and also the components. Okay, so we have the class diagram, component diagram, package diagram, deployment diagram, the use case. So this one, class diagram, you'll be needing it. Components, you'll be needing it. Use case, you'll be needing it. Sequence diagram, you'll be needing it. Activity, this one, you'll be also be needing it. So these are the key ones that you need. So all of them are in the PDF. Okay, you'll be needing them a lot. So you need to actually master it. If you go to YouTube, okay, you will see them live and colored. Okay, so these are some of the UML diagrams. And this video, let me copy it for you. And all courses under Field Code Camp are actually very clean, and you can learn from there. Okay. So let me put it in your message. Okay, so I'll put the link in the Zoom message, so you can just copy it and do more. And I'll be asking you questions there. So even in and also these people, Lucy Software, they have a great platform for some of this. So let me copy this Lucid Software. Yeah. Oh, no. So look for at Lucid _ software. on YouTube. Ah, yeah, I didn't get there. I didn't actually put the diagrams in there. So when you come here, you will actually want to look into them. Mm, yeah. So the sequence diagram is very, very key and all of that. All right, so guys, I will end here and I'll give an assignment on this chapter 5 to as I told you, you're not going to write any code. Okay. And now the chapter 5, the assignment is going to dwell mostly on the UML diagram. Okay. It's going to be dwelling on the UML diagram because here, even though there are some coding aspects in terms of the design principles, you are not going to write any code. But for it's better you need to know the UML diagram, okay, how to develop it, how you can explain. So I'll give an assignment and I also require a YouTube video where I need to see you there explaining how those diagram really works. So for example, let me give you see how this guy appears in the video.
Hi,
Yeah,
my name's
see,
Colin, and today
something
in
like
Lucid
this.
Training Labs, we're talking about business process model and
Okay, I need to see you in the
or
video
BPMN.
somewhere in the
We'll
corner
start
here.
with a high-level overview. In a diagram, events are
Okay,
shown as circles.
some of them, let me see.
A start event
Some of
is a
them you
circle
may see,
with a
let me
single
see.
thin line.
No,
An intermediate event is a circle
I'm
with a
coming.
double line. And an end event is a
I'm going
circle.
to show you how the video should look like. Video presentation. Yeah, new.
So you're ready to hit pub, and then you can literally paste it. We good. Time, I'll fix it.
No, I want to show you. I'm coming. So tell this school. I want to show you how. No, I want to show you, like as you are explaining, there you are somewhere in the corner here, so that I can see your face. You see, like this guy. You see the way the guy is at the corner here and explaining what the code is doing. Basically, that's what I want. I hope that one is clear.
So did you say we should create a YouTube video?
Yeah, with the documentation.
Oh, okay.
Yeah. Yeah, I think so. Let me see. Yeah, let me open the project again. Oh, hold on, let me open the project again. Let me check something. Let me be sure of what's. Mm. So this one, I just want you to know, I want individual projects. I don't want group work. Okay, just for you to know, I want individual project, and the deadline still. Oh, it should be 2026. So please update it to change to 2026. So you can see the use case modeling and this. I really need them, and you should be able to explain This one, I don't think there's any video. No video is, I didn't attach, I need the documents. And I may call you at any time during lectures for you to explain. Unable to explain, which means that you just went on the AI to get it from me direct without understanding what it really is. Or examination, I ask similar question, and if you're unable to do that, then it tells me that you really went there to copy the code. You just went to copy the AI and without even understanding. All right, so if no questions, I wish you guys the best of the weekend, and let us continue to stay safe.
Thank you, and same to you, sir.
All right, thank you. Bye-bye.
Bye.